Hello, everyone. Welcome to the Wednesday Solder Sesh. I am Carrie of Alpenglow Industries, and I have with me today Kelly Heaton. And I'm really, really excited. She's an electrical engineer, and she also makes amazing, giant, and functional circuit art installation. And she has one of them on display right now in New York. It's called Circuit Garden, and we're going to talk oscillations and some of the circuits that she used to make it. So awesome. Welcome to the stream.
Thanks. It's good to be here.
Cool. Well, I figure I will start. So right here we can see on my workbench here. So this is a schematic for part of the birdsong circuit that you shared with us. And it's all made of transistor oscillators. I'll start to piece one together here on my breadboard. And I would love if you could tell us basically like how you got started in STEM, kind of like your earliest STEMish memories, and how did you get to doing giant, cool circuit art installations?
Wow. Okay. Kind of a long story, but I can.
That's perfect. We like long stories here.
All right, the circuit, so talk. So yeah, the circuit you're building, by the way, is just a classic astable multi-vibrator oscillator.
Yes.
And for your information, it is not necessary to put two LEDs in parallel. You can just use one.
Yes, we use the same circuit on one of our like little soldering kits. It's our I voted one that we made around election time, and it oscillates between like 4 blue LEDs and 4 red LEDs and goes back and forth. So
yeah, amazing. I absolutely, that's my favorite circuit. I absolutely love it. I use it everywhere. Okay, so how did I get into STEM? So I have been an artist for as long as I remember, and I always ever identified as a visual artist. And growing up, I had a real love of nature, so nature was a continuous source of fascination, and I have pretty early memories of wanting to build, at the time, what seemed like magical things, like a bat or a squirrel that would fly along tracks on the roof of my bedroom. I also wanted to. So my mom was. My whole family was big into nature, and my mom used to take me on these trips with the Museum of Natural History called Amphibian Alert, and we would go in the spring, and the sound of the spring peepers chirping, that sonic, immersive, visceral experience had a huge impact on me. And it was something that I just imagined, like, how cool would it be if you could capture that, if you could recreate it. But I didn't grow up in a family of engineers, so I had no language for anything STEM related. I did have a Commodore 64 computer, and my brother and I would play around with that, but I wasn't, frankly, that drawn to computers. Like, they were just not visually or sculpturally appealing to me as objects. I just saw them as like a beige case.
I was just gonna say, a beige box was not appealing to you with like brown keys. Whatever not. Yeah. I think Commodore 64 had a tiny rainbow on them, didn't they?
I mean, it was like a novelty that you could, play with them a little bit, but the video games back then were not that interesting. There weren't great regular graphics, and we had an Atari game console, but it never occurred to me that I could hack into it. Long story short, I was privileged to have technology in my life, but computers to me were synonymous with like things that boys played with or the computer that I had to write my high school papers on. So that was pretty much it for me. I was not a STEM kid, with the exception that, given my love of nature, I did get interested in biological science. And this was something, running in tandem with art. I was also, by the way, I mean, adults in my life were like, art's not, you don't make money as an artist, right? You know that. So you need a career, you need some way to make money. I railed against that, and I still do. But in college and then after college, like I bounced around a lot because I couldn't find my voice. I wasn't a traditional artist. I mean, yes, I drew, I painted, I sculpted, but I wanted something more. There was this part of me that was always drawn back to science. So I actually went to veterinary school for a while and then dropped out of that to go to my Master of Fine Arts and dropped out of that. But prior to dropping out, I had a fateful meeting with my neighbor in my studio complex, who was an MIT graduate, a man named Kevin Brown, who is the founder and owner of Brown Innovations. They're an audio engineering company in Boston, or were at the time. I assume they're still there. Mm-hmm. And Kevin saw that I was using a lot of scientific metaphor in my art, and he said, you should go to MIT. I was like, you are insane. I had no, I had taken like up to calculus in mathematics, and I did have a lot of biological science in my background because I took it all to get into veterinary school. So that was okay, but engineering and math and all the things you think of when you think of MIT, it's like, yeah, I had none of those qualifications. But one thing led to another, and it also happened to be, it was the end of the 90s, the dot-com boom was happening, there was a lot of money going into creative, innovative, out-of-the-box, radical thinking. And I met Michael Hawley, who's unfortunately now deceased. But Michael Hawley was just an incredible creative, like, there are no limits, like, there isn't a problem I can't solve. He was really a wonderful thinker. And he invited me to join his research group at the MIT Media Laboratory. And 3 months later, I matriculated without ever having applied to MIT. I did later. I think I remember filling out the actual application forms, but I mean, how crazy is that, right? So my education started at the Massachusetts Institute of Technology, which is stranger than fiction, but that's what happened.
I love it. I love it. Yeah. I love the atypical way of matriculating too.
I mean, there were so many things that had to go right. It was a miracle, really. It was a miracle of being in the right place at the right time, meeting the right people, and also having, I mean, it wasn't like there was obviously something about me and my hybrid creativity that they were attracted to. And I had, I was definitely using a lot of chemistry and biochemistry metaphors in my artwork. So I had that kind of thinking. Mm-hmm. And again, with the dot-com thing exploding and so much optimism happening in the late 90s, I think Michael Hawley and the Media Lab felt like, well, why not give it a try? Let's take an artist who has obviously a penchant for science and scientific thinking and put her in the Media Lab environment with computer scientists and electrical engineers and see what happens. And that's exactly what they did. Now, what they didn't tell me was that I actually did have to take classes. Like I had to, I took John Maida's Design by Numbers courses, and I will never forget. This is no joke, okay? My first computer science class ever with John Maida, it's like going to the moon, right? For STEM. My first ever computer science assignment was John Maida saying that I needed to write a Java app that would load in a photograph and a simple tool where I could draw on the photograph and then convert the photograph using a fast Fourier transform to whatever weird image that became, be able to draw on it again, and then do a reverse fast Fourier transform. So I was like, oh my God, I mean, how many people about this are wrong? Like, what is an app? What is Java?
How do you spell Fourier?
I mean, how do I? So what happened was and this is actually, I mean, this defined my entire career at the MIT Media Lab. I had no choice but to tell my story of like, okay, I'm the token artist that Michael Hawley invited to join his research group, and I'm screwed because I don't know anything. So please, like, work with me. I'll buy you a pizza. I'll make you a drawing. Like, I'll help you design your product casing or whatever. Please let me do my homework. And so I had just wonderful colleagues when I was there who would give me snippets of code. I mean, they wouldn't do my homework for me, but they would give me snippets of code. You know, for example, like the shell of an applet. So I was then able to like go in and make some adjustments. There's a lot of collaborative, and it was supported. I mean, I don't think that we were plagiarizing or anything like that. It was understood that it was it was hard, and that we had to help each other. But so yeah, I mean, I learned how to write code basically by on the kindness of my colleagues, my friends at the Media Lab, and
well, they don't tell you this, but that's how life goes after school, is like you learn from other people and from collaborating on projects and from other people teaching you things. And
I'm still doing it.
It's funny how in a lot of school settings, like that is not only not the norm, but like specifically forbidden, right? And it's kind of weird. It's kind of weird.
And especially in technology, there is so much to know. And even if all you did was focus on the fundamentals, by the time you like got your head out of your, out of your books, the world would have moved 20 or 30 years beyond, and technology would be so different that your knowledge wouldn't apply any longer, or at least not in a traditional way. So, I mean, we're all scrambling to keep up, right? With changes in software and technology. Recently I was thinking about how, and by the way, I'm soliciting your input because I hear different ways of saying this, but is it KiCad or is it KiCad?
Oh, there is a great debate about that.
Well, I like to say KiCad, but if that's wrong, I apologize to the developers.
I'm in Camp KiCad.
Okay.
I have heard that the proper way is KiCad. However, nobody seems to care overly much. Like, anyway. People have their favorites, but I think either one goes.
All right. Well, we all know the fabled software that we're talking about. And I've been using the same version of KiCad for, I don't know, probably 4 or 5 years. And it's like totally old version. It's just like moved way beyond where I am. And I'm just dreading the day that my old KiCad version doesn't work. But okay. I mean, because stupid things like that, just downloading and installing and finding out a new interface. I mean, that occupies so much of our time anyway, just to say that when it comes to writing code or building a circuit, do not reinvent the wheel if you can avoid it. Like find somebody who knows how to do it and build other people's schematics and then slightly tweak them to make them your own. And eventually over time, suddenly, you have something that's all your own, right?
Yeah, exactly. And I mean, we all start somewhere. I think it is definitely easier to learn when you have an example in front of you that is relevant, right? or that you can then dig into and start to modify to do other things.
Yeah.
And it's a long time, and it's just repetition with something that gets you to that familiar point where you can just like come up with it from scratch on your own, right?
Totally.
And
Yes.
yeah, and like there are so many things that I think are like kind of basic electronics or basic computers where if I am not like looking at it for 6 months, if I take a break, I have to look it up again, and
Right.
like
Oh,
that's okay.
sure. So fun.
That's okay.
What about like 1 week or even
Yeah.
4 days?
I
Yeah.
was trying to be generous, but
Yeah. No, I mean it's just overwhelming. There's so
Yeah.
much to know, so many different parts to pull together. Even things like learning how to navigate like a vendor website, DigiKey or Mouse or I mean it takes a long time even to just know how to order parts,
Or to
let
know what things
alone
are
what you
called.
did first order.
Yeah. Yeah, I mean, think of how much time you've spent searching the internet for something that like exists. You have a vision in your mind of it, but you
Oh
just
yeah.
don't know the right things to call it by or what other people are calling it
Oh,
by.
oh, the pain. Okay, so that pretty much describes like the 20 years of my career after I graduated from MIT until, just a few years ago, because as I described, I collaborated extensively at MIT. Like I made a lot of electronic art, but only thanks to my collaborators because I wasn't capable of doing the engineering by myself. I was learning on the job, but still, like by 2 or 3 years by the time I left MIT, it wasn't like, oh, okay, now I know everything. And actually, interestingly, it wasn't until many years after I graduated from MIT that I became a good enough engineer that I qualified to go to MIT. So, seriously, I mean, and in that time when I was teaching so I got really interested in analog electronics when I was at MIT because two things.
Yeah.
Software was trapped in a computer, and
Mhm.
I paint as well, but I am also very much a sculptor. So the physical form, the physical presence of things matters a lot to me.
Yeah.
So, you show me a piece of code that's on a screen someone else made, and all I can do is look at the screen and be like, but it's flat, but it says, I want the screen I want to be able to manipulate it. And
Have you gotten into fiber arts at all, like knitting or
yeah,
things like that? Yeah.
yeah.
That
Well, and the components in circuit garden are all sewn.
Sure.
But
Okay. Yeah.
just to quickly wrap up that line of thought, though, that I was
Yeah.
on. So it took me all of this time after I graduated to learn analog electrical engineering, and I was mostly just doing self-study and scouring the internet for anything that I could understand and build. But to your point,
Yeah.
I didn't have the language. I mean, something with circuit like an astable multivibrator. I mean,
Right. What is that?
ever know to look for that? I didn't
Yeah.
even know things like, oscillator. It just
Yeah.
didn't, because in my mind, it's like, well, I want to blink lights. Well, how do you go from I want to blink lights to, oh, by the way, that's an oscillator? You
Yeah.
just don't make those connections. And it's not because you're stupid. It's just literally like
You
this
just don't know.
massive language learning process. So, and all the abbreviations and learning to read schematics and wow,
Yep.
it's amazing how long it can take to build something that seems relatively simple in your mind, and in fact is often relatively simple in reality. But you just don't have the right words to even know where it is.
Yeah.
So, yeah. I mean, I respect you're putting potentiometers in your breadboard. I remember spending months trying to figure out how to wire up a potentiometer. Like I remember like, oh, it's a knob. Okay, cool. I get that. And one arrives in the mail and it's got these three legs and you're like,
Whoa.
what? Why does it have three? Isn't it just like low resistance, high resistance? Like what's the leg in the middle doing, So
yeah, it took me a while to understand what was meant. I kind of had the opposite thing where like it took me a while to understand when I first saw what was meant when you have the middle connected to one of the legs, right?
yeah.
Like I'm like, oh, okay, you've just turned it into like a single variable resistor.
Well,
Oh,
and
okay.
you know what? I do that all the time by habit. You can see that I've done that in my circuit, and the reason is that is precisely what I was describing. Like I just wanted a knob that would go from one resistance to another.
Yeah.
And in my first, so it's a habit now that I've just carried on where like I just take a pot, I'm like, 3 legs is too confusing. Make it 2 legs and move on.
I like
Yeah.
it. I
Anyway,
like it. Yeah. Wow. So what was your first job after MIT? Oh, and
after
also hi to people in the comments. Oh, David wants to know where he can get a cool cap.
oh, so thanks for asking. Yeah, my power cap.
You know.
So right now the answer is nowhere, but I am working on it. So not only do I want to make power caps, but I also want to. I don't have it down. I should have brought it down, but I have this resistor backpack that I made that I want to make like backpacks in many different stripes, like resistors of all values.
Yes.
So yeah, I love fashion, and I'd really like to make electronics inspired clothing. Just yeah, to like empower everybody to take part in electronic culture.
Yes.
It frustrates me that engineering is so inaccessible to the vast majority of the population, and
Yeah.
yet technology is controlling everyone to a great degree. I find that disparity hurtful,
Yeah.
alarming, dangerous. I mean, there's so many things about it that are wrong.
Yeah.
So anyway, yeah. So one
Agreed.
of the ways I plan to address that in the coming years is to make a line of really cool electronics inspired fashion to empower the people.
Yes. I love it. I love it. Yeah, I mean I feel pretty passionately about that too. And part of the reason of just like doing live streams and hanging out is to just like build circuits and learn stuff about circuits and get more information out there for people. The more
Yeah.
people talking about electronics and explaining stuff in different ways, I feel like the better we are. Even if it's the same circuit explained 100 different times, 100 different ways, some of those ways are going to connect with some people, right? In ways
Yes.
that those other 98 did not. And
Right.
so, yeah.
Yeah.
Yep.
And I mean, speaking of the astable multi vibrator, I
Okay.
have a pretty solid intuitive understanding of how that circuit works now after working with it and building hundreds, if not thousands of them over more than a decade of my practice. But do I still completely understand how the electricity is moving in it? No. Am I continuously developing new insight about exactly how the circuit works? Yes.
Yep.
And that's one of the things about analog electronics, which is so cool. And that's also why I want to get more people passionate about electronic hardware, because there's tremendous potential in analog electronics that is underutilized. Because in the 60s and 70s, when electronic devices were miniaturized and manufacturing processing was improved, they became more readily available. There was like this brief period in human history when hobbyists could have pretty easy access to electronic supplies and built some amazing analog electronic circuits with them. But by the middle end of the 70s, that was already ending because you had digital integrated circuits coming out, and all of this everybody like just left analog. Oh, it's too hard. It's easier. You know, you work with these chips, and yeah, people move towards digital really fast. And now I get frustrated when I apply for art competitions or art grants that the categories are like, okay, you're either it's painting or sculpture or digital art. I'm like, no, like that's not fair. Like that's not digital art is not synonymous with electronic art.
Right. Yeah. No,
But
that's a really interesting point. I hadn't thought of that before. Yeah.
It's almost that bad.
Yeah.
So we need to get people back thinking about hardware, working with hardware, and also looking at what analog circuits can do. And that's why I developed my birdsong circuits, was to show people like, hey, using a very small amount of hardware, I can get really interesting, complicated behavior that were you to do this in a digital way, it would require thousand-fold, hundred, maybe million, I don't even know. Like, because for starters, you have to have like the computing processor is your platform. And with chip shortages in the world and everything, like already getting that chip, that very basic computer, even an Arduino or whatever, you're already talking about like tremendous manufacturing and sourcing complexity, right?
Yeah.
Right. So
Yep.
like, what if you could build the same circuit with like 30 discrete components? You know, I mean, people buy Arduinos to blink lights.
They do indeed.
But now you're going to show them that they don't need to. Right.
It is true. It is true. I mean, you know, I don't think I can necessarily pick a favorite because I do really enjoy embedded programming. It makes you think in much smaller, simpler terms. I mean, you really do have to think in ones and zeros a lot and think about like how many ones and zeros is represented by this number that I'm putting in my code and things like that. And like, what happens if I OR these two ones and zeros together? What happens if I AND them together? And something about that I really enjoy, but I also really love analog circuits too. And I like, I don't know if it's like the retroness or the retro appeal, but it is really cool to have something that does a thing that you don't program, that just does that thing because of the nature of the components involved.
Well, I mean, you do program it in the sense that you are still building an intelligent architecture. You can't just throw a bunch of transistors at your breadboard and have them like magically.
Yeah. But I wish you could. So that would be great.
Trying to think about it. Another circuit that would be really cool to build, especially for you, are transistor logic circuits. You know, you can use transistors to AND and OR and XOR.
Yeah. Oh, speaking of something that's kind of a cool crossover, I recently saw the latest Tindy newsletter. Somebody is putting together a core RAM board. So you you actually, I believe you have to like actually like wire the ferrites yourself and like make the lattice yourself on the board. Okay. And I'm just like, oh, core memory. Oh,
core memory is beautiful.
Yeah. So I'm excited. I think I'm going to pick up that kit and maybe that will be a future solder sesh.
Oh, definitely.
Yeah. Ooh, so Pat in the comments says that electronic inspired fashion would be amazing, and that there's an opportunity for women in hardware to speak at Grace Hopper's celebration, and the call for proposals ends May 4th. So, and they would be glad to provide a link.
Yes, please provide a link.
Yeah. Yeah, it's unfortunate that you can't link in the chat, but I understand why. It's a spam thing. But yeah, if you can tweet about it or like send it to us, message it to us or website, that would be great. That would be great. You can always do info@alpenglowindustries.com, email too. Yeah.
Cool.
Core memory. So yeah, David is saying that there's a core memory Arduino shield. I think that this is I think it was an Arduino Shield form factor that I saw. I thought it was like new, but maybe it was, well, at least Tindy, it was new in the Tindy newsletter.
Yeah.
That's cool though. Maybe there's more than one. Ooh, cool.
I unfortunately can't remember the name of the creator, but 6 months ago, I don't know what is it? Hackaday has that live chat, but it's not.
Oh yeah, hack chats. Yeah.
Yes, thank you. Yeah, I did a hack chat or participated in a hack chat like 6 months ago with a really interesting creator who builds core memory, and I wish I could remember his name to share it here, but I'm sure if you search Hackaday and core memory, it'll come up.
Cool. Definitely have to check that out. I'm trying to figure out what size I need for, I think, almost my last inner connection, at least in this circuit before I connect power. And I think I need it.
Your circuits are so neat. I'm truly blown away.
I don't know. I like the trying to be tidy because I'm not tidy in other ways. So
look at what's on my bench, which is like,
yeah, but that's kind of awesome. It's
yeah.
Great. I like seeing the mad scientist chaotic look.
There's another. This is another one of my birdsong development boards hanging out here. This is not unusual. I mean, that is like my modus operandi. You know,
I love it.
Life is too short to strip wires of identical length.
Yeah, actually, like I kind of want to. This is like ridiculous and stupid because it's probably going to be more effort than money making, but I want to make better breadboard jumpers. So I actually really want to make a machine that like specifically makes breadboard jumpers where you can sort of dial in your own length and maybe we'll even do different shapes for you and stuff like that. Yeah.
Yeah. You know, it's funny that you say that because, well, so my first collaborator when I was at MIT is a guy named Stephen Gray, who's now head of a makerspace in Charlotte, North Carolina. And he built the most beautiful, tidy circuits like you're building. You know, everything was so organized. And so I used to razz him about that. But he introduced me to those, you know, kits you can buy where you have wires of different colors and different lengths and everything. And all the ends are like perfectly crimped over and stuff. So I have purchased these fabulous kits in my life, but the problem is that the wires are so perfect that I get this scarcity complex, like, oh my God, I can't use them because I'm going to run out. What would I do if I ran out of the like perfect orange crimped wire? Whatever.
Well, okay, so that is an issue, right? Because the orange and the yellow ones.
We need your tool.
Yeah. Okay. So I am very interested, David Levi. I'm not sure how to pronounce your last name. I'm sorry. But I am very interested. You say you have that machine. I need to know more about this wire bending machine.
Yeah.
You've spent a month setting up a breadboard wire machine. That is awesome. Like, I would love to know if you have if you've shared it online anywhere or anything like that, because man, do I want a machine like that. I would love to make better wires. And I would also just love to be able to sell like any length and shape that other people need, because I think it's really annoying that, I mean, I know why they do the color coding by length, right? It's to make the right length easy to find, but that makes it so that you can't color code your signals. And I hate not being able to color code my signals on a breadboard. So I would love to just be able to like sell like every length and every color and just be able to like make them whenever we get an order in.
You can just tidy up all the wires of the world. You're excited to come to my studio.
Right? All right, switch for YouTube video, automatic breadboard jumper making machine. So I've actually talked to some people, to some manufacturers in China about this. And the thing is that they're not actually for wires that are this small. They're actually for much larger wires. And I talked to them about doing the breadboard application with like 22 gauge solid core wire, and it just wasn't something that they could do because everything was just too big. Like the smallest ones that they could do were still pretty wide. You couldn't get to that like you know, 2/10 of an inch spacing. But maybe there's more now, but that was the situation like a year ago when I when I was really looking hard into this. Cool. I'm interested about the Pensa wire bender too. I'll have to see that. Oh, nice. So David has already done this. This is great. So he has a company, Microkits, and bought the machine from China. Can make 800 an hour. That's cool. Interesting. I must have been not like talking to different people then, because it was not. Yeah, I was very sad that it was kind of a bust. That's super cool though. Nice. Mini modifications. Yes, I can imagine. And then you had to spend a couple months modifying it more. Yeah. Oh man, interesting. Yeah, I would love to learn more about that. That's cool. And yeah, if you're already doing this and selling breadboard jumpers in whatever size and whatever color, definitely drop me a link too, because we will share that in the description for sure. Cool. So, okay, Kelly, tell us about this awesome looking circuit that's on your bench and the birdsong circuit. I think it's super cool. I have a few questions about different parts of it too here. So, but I would love for you to kind of like do the overview first.
Yeah. Actually, this one is going to be. I have a couple of them sitting here. This one's easier to plug in, because this one's got a wonky connector. But I'll let you hear it first, because I think that's the easiest way to introduce it.
Yeah.
So
that is super cool.
Right, so I just turned the sound off for a minute. Mm-hmm. So the sound that you were just hearing is being dynamically generated by the analog electronic circuit. And right now, the bird thinks it's singing. I've just disabled the switch to the audio, the speaker line. Mm-hmm. But what I'll do next is start to twist some of the knobs, which are the base resistors of the astable multi-vibrators. Mm-hmm. And you can hear how the oscillating circuit and therefore the bird song changes with that. But I just wanted to play it for a minute without touching anything, so you could see that like the circuit makes remarkably complex sounds with only 5 astable multi-vibrators and a modified Hartley oscillator.
Yeah.
That combination.
Yeah. It was remarkably natural sounding in complexity. Yeah.
Right. And the pauses in between and everything. So so you see how by changing the bass, it changes the song pattern. So you get different syntax.
That is really interesting.
Yeah. Thank you.
No, that is very, very cool. So that's actually a perfect lead-in for some of my questions here, which is, I think, that the most interesting part of this entire schematic. So I'll show you this. I'm gonna zoom in so that people can see it in a little more detail, hopefully. Maybe not so blurry detail. There we go. Okay, so the schematic is mostly these little sections, which are and those are the astable multivibrators, and they basically work by alternating off and on these transistors, and that is controlled by like a little charge pump capacitor circuit. So, once one of the capacitors is relatively charged, Then it opens up the base on this transistor, which opens the path from the emitter to collector. And then so then you have like this side of the circuit that's on. But then as soon as that happened, because they have this cross-coupled feedback, then what happens is this side of the circuit starts charging, and then as soon as it gets above the base voltage, it turns on and the other one turns off, and so you keep getting this back and forth.
Exactly. And they're pulling each other.
Yeah. And then all of the characteristics, like the frequency and things like that, can be adjusted by the different components in the circuit. Yeah. And so let's see, you have 5 of these, and they're all they're set up a little bit different. They have different capacitor values. So like this one has 220 microfarad caps. This one has 100 microfarad caps. And of course, you can change the resistors here. Those are these guys are the potentiometers, the knobs. And then you got 47 microfarad caps and 1 microfarad here. And then
47 twice in the circuit, which is, so I have since made some changes to the circuit to try and get as much diversity of sound out of it as I possibly can. But the Blue Jay that you just heard is exactly that circuit that you have.
Cool.
Point being that this particular model has a lot of options for modification and expansion. The addition of more oscillators that are coupled, right, to make even more complex sound patterns. Essentially, the circuit can be thought of as 5 astable multivibrators whose purpose is to create syntax, meaning a grammar. It's an architecture, of a pattern architecture, so to speak, for one modified Hartley oscillator, which comes from the classic electronic canary birdsong circuit you can find widely on the internet. By capacitively coupling the 5 sort of syntax oscillators, if you will, to the 1 voice oscillator, right, that's where the connections are coming in. And you can see that I've got the capacitors there, which then if you go up on the schematic, up, there's, not too far, there we go.
There we go.
So that's the point at which those 5 oscillators are connecting to the base of the transistor that's controlling the chirp of the audio transformer. So that's the voice mechanism of the bird, so to speak, like where, the quality of the bird's sound comes from. And in that part of the circuit, if you make modifications to those capacitor values, you can make the voice either higher or lower pitched. The values that I chose are just, I think, the most kind of generically bird sound like. But yeah, I mean, that's it. It's really simple. It's just 5 oscillators controlling 1 oscillator, where the 5 are for pattern and the 1 is for the voice generation. And
I'm curious about this mixing section.
Oh yeah. Okay. So
yeah, talk about that.
Yeah, that's another area where there were literally so many different ways I could have designed the coupling that I just sort of picked one that I was like, okay, well, this one is cool, but there were so many other cool ones too.
Why did you pick this particular one?
Because I liked it.
What did you like about it, though?
But I mean, it's really that's it, because that's how. Let me move this guy out of the way, and I'll show you my breadboard here for a sec. I don't really spend a lot of time planning my circuits. It doesn't mean I don't do research. I do. Like, I'll have a concept and then I'll go scour around on the internet to see what existing schematics I can find that I can modify.
Mhm.
The electronic canary being one of them. But if you build that electronic canary circuit like as it is on the web, it just goes chirp, 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 chirp,
Yep.
chirp, chirp, chirp. It's like cool but annoying.
Which is sometimes what you're going for, but sometimes not.
So I wanted to, give it, like I said, more syntax to make it more like real bird song like.
Yeah.
But yeah, once I got the basic architecture of the circuit in place, like the concept that there are 5 oscillators that make the syntax and one that makes the voice, then like how I coupled them and so forth, like those component values, the capacitor values, or a diode or not a diode, or put the diode somewhere else, or swap out the wires. I'm going to show you that here in a second so you get a sense of what I mean. I mean, there's a lot of potential for expansion in the circuit. So, and I'm working on those right now. I'm working on a product that I can sell so people can have one of these and play with it.
Yes.
I'm also in conversation with researchers who study bird neurology, right, and birdsong.
Cool.
To look at ways that this circuit may support research and to understand, because I really think
that's cool.
It's an interesting model for essentially how a bird's brain works to generate birdsong. Anyway, let me plug in my breadboard.
Well, let's see. Am I doing this? Am I doing this right? No, I need the. I'm almost done, I think, with the last connection before power.
Okay.
Cap. Oh, there we go. Okay. All right. Oh, so we got lots of questions. So David says, have you done any networked birds? And also, where will we find these projects?
So
I believe he means like, how can he get a cool chirping bird kit is pretty much what that means.
So I'm working with an industry partner on the bird kit, and I can't say anything yet because it's not. But it's happening.
Cool.
So, hopefully it will be released this year. I mean, we're working on it.
Nice.
Meanwhile, my schematic, the schematic that we've been referring to this evening, is available on my website under a project called Deepfake Birdsong. There are lots of videos of my various circuits and my process that are web documented on my Vimeo site. So if you look for Kelly Heaton on Vimeo.
Nice.
I also for those of you that are audio enthusiasts and appreciate this practice that I call electronic naturalism of building these lifelike circuits. I didn't start with birds. It took me years of experimentation actually to develop the insight to even know how to make something sound bird-like.
Yeah.
And but I started with fireflies and crickets and made lots of different kind of chirping cricket sounds. I documented that process on Hackaday as part of a project called Hacking Nature's Musicians from 2018. And you can, read about like how I was learning. I do at the end of my various project logs talk about developing birdsong because in the fall of 2018, I got an artist residency at Tortuga Escondida, which is a research center in Acamal, Mexico. And I went down and focused on developing bird circuits actually at my bench in the jungle in the Yucatan Peninsula. It was so wild. I took this little mini oscilloscope with me that fried because of the air. But anyway, yeah. But it was pretty cool packing up my electronics bench and getting it through security at the airport in Cancun, Mexico. That was pretty fun.
They're like, what is
I was
this?
kind of nervous. No, they didn't, they didn't hassle me, but I was worried. I mean, I do worry that like the FBI like wonders why I have so many electronics, and I mean, I don't know, I'm probably not that important really, but don't you ever wonder that when you're buying like tons of electronics that people are like, what is that? What are they up to?
I would love to know what my file says at some point. I actually just want to know what Facebook thinks about me, because like from the ads that I get, I kind of wonder. I'm like, I don't think you're doing a very good job with your predictiveness there.
Oh, wait, now I want to know, what are your ads?
Oh man, it's been a while. I haven't been on it recently, but I was like, I don't know. I was getting some weird ones, and I actually remember it. I remember a friend of mine saying, "Yeah, I bought a 5-gallon bucket once, and I keep getting ads for horse feed years later."
Yeah,
And it's like little things like that.
that's funny. That's funny. Because I don't, advertisers has no idea what to do with me either, because like one minute I'm buying like high heel shoes and the next minute I'm buying like transistors. They're like, okay, that's not our like target demographic, but yeah. Anyway.
So there are a few comments about Euro racks and about how like the 5 multivibrators brings to mind like the ASDR, attack, sustain, decay, and rest modules on a Euro rack, so that you can like just kind of modify each one. And Euro rack birds when is also a question.
Wow, you know what? I love that question, and if you want to collaborate with me to make that happen, I'm a visual artist. I mean, here I am talking to you about analog electronics songbird generation. Like, I don't even know how I got here. I'm a visual artist, but anyway, yes. I mean, clearly I know a lot about analog electronics, but I'm not a musician. So you'd be amazed by what I don't know.
Yeah, no, we've put together a few oscillators kits, which are done by a maker named Tommy, and he's basically made these little like 555 timer, like little piano synthesizer kind of things, and they're way silly and fun to play with, and we love putting them together. And then we mash a few keys, and then all of us like look at each other and we're like, okay, well, I don't know how to play anything. But it's fun to mash the keys. And so like, I don't know, I think that like with this birdsong, it's like it's fun to twiddle the knobs, right?
Totally. I mean, I spend hours doing it, so I figure other people will like to do it too. And I'm also in the bird that I'm working on producing as a product, so anyone can buy it. I want to put some panel switches where each of the 5 oscillators connect, and they all come to a common connection eventually, but I want to put a panel switch in there so that, well, basically you could reproduce what I'm about to show you in my breadboard, which is just like removing an oscillator from the equation. Like just removing it. You're like, well, how does it sound like if I take this one out? Now, what I can do in my breadboard that is not so easy to design into a low-cost PCB is I can actually swap the wires and look at how that changes it, which is really fun to play with, but not so sure how to easily do that in a PCB, but whatever. But let me show you what I'm talking about.
Yeah.
So you can see it. So one of the oscillators here is connected with this yellow wire. So I can just, oops, sorry about the camera. Anyway, you get my point. So that's just all I was doing in that case was removing oscillators from the system. And it's funny how some of them don't have a big effect, but actually, it's not just that some of them don't have a big effect. It's also about timing. Because it all depends upon the state of the analog system, like which capacitors are charged or not charged.
Right.
And so sometimes you remove it and it doesn't do a whole lot, and sometimes you remove it, it does all, and it's like huge, you know. I just love analog. It's so expressive. It's so full of possibilities and unpredictability that you don't get with digital.
Yeah. It's fun to be able to change things at different points in the, in the signal path too.
Yeah.
Yeah.
It really is.
Yeah.
And also the other thing I love is like trying different transformers, trying different transistors, trying different capacitors. I mean, musicians already know this, but they all sound different.
They do, yeah.
With the material properties of the electronic device, and they're not all the same, and that's just so wonderful, like that mind-body relationship that I feel like engineers often forget, or like, what, is there anything below here, right? Well, yes.
Cool. So we have some good questions and comments. So there's a lot of love for the color coordination. Definitely. I noticed that as well. I like how how you've set your LEDs out in rainbow order there.
I mean, who doesn't like rainbows? I
know, right? There's the suggestion that you could use dip switches for the PCB in order to just like turn on or off different signals in small space.
Well, so that's what I am going to do. What I don't know how to do is to be able to facilitate like completely.
Completely swapping. Yeah.
Yeah. Well, and there's I don't know. I'll mess around with that. But anyway, but even just being able to turn them on and off, that adds another cool factor, because when I was unplugging them right then, I still wasn't even modulating the base transistors.
Right. Yeah.
Right.
Yep. So we have a question are the oscillators phase coupled or just free running? And
I have no idea.
I can help with that answer. So they're just free running. I mean, the way that these transistor multivibrator circuits work is that they actually rely on slight differences in component values in order to get them going. Like if they were actually, if the components were exactly the same, if the sides of the circuit were exactly perfectly symmetrical, they would never actually start. You need like a little bit of an imbalance to get going. And so there's no, there's really like no phase signal between these that's syncing them or coordinating them in any way. Now, that's not to say, I mean, we're doing a lot of things here. So that's not to say that they won't necessarily get into some harmonics every now and then, because
they do.
Yeah.
So the reason why I was laughing and saying I have no idea just to like reiterate that.
Yeah. I
don't really know what I'm doing. I've just been doing this now for more than 20 years. And I've made some cool stuff, but like, I don't approach it like an engineer does. I'm not like, oh, okay, I completely understand, audio structure, and now I'm going to set out in a deterministic way to achieve a result.
Yeah.
I can't do that. I couldn't do that if I tried, like I just can't do it. So I do everything by trial and error, and I just bricolage and I build off of my existing practice. And anyway, so for those of you who are feeling a little bit like down on your engineering knowledge, hopefully that will be inspiration. Like just keep going, build cool stuff, and keep modifying it. And, you might invent something pretty neat.
Definitely. And I don't know, I've always been one who would rather build an actual circuit that you know, with my hands, that is a physical thing, rather than spend time modeling something in like Spice, because that's just
I've never
the computer, right? It's not as fun. Like, I would rather build it and be able to like actually see the correlation between like touching things and modifying things and what the output is, rather than seeing a waveform on the computer, which is informative, but just not as inspiring to me.
I have never used Spice.
Yeah.
For me, Spice is something I cook with.
Yeah. Yep. So, okay, I think I've hooked this up correctly. We'll see if I pop any capacitors or if smoke comes out. But I think we should have some blinky oscillations if I hook this up. I'm going to be a little conservative. So you're powering everything off of 12 volts here, which makes sense because you have a speaker and you want it to be nice and loud.
2 volts is fine. 6 volts works.
I was gonna say,
Even 2 volts. Well, maybe not. 4.
I'm gonna do 5 to begin with, just because 5 is a good number. All right, and I have red to red. I have black to black. I've hopefully double checked things. Oh, we don't have any blinkies. Am I all on and stuff here? I am all on and stuff here. Okay, let's see what I have not done. All right.
I don't see a ground connection on one of the transistors.
I have so I have the ground hopefully going across and going into this ground here on the breadboard.
Yeah, so, man, those wrong colored wires, you know, here I am like, I'm not type A. But...
I know. It's also a little bit difficult to tell which side of these LEDs are proper because they're so small. But at least one of them should be in the right way, right? At least one of them should be blinking. Let's see. I think they're all in the right way. Okay, so we have power coming in to our LEDs and power going across here to our LEDs. We have those guys going to the resistor, those guys going to the resistor. And then we have the resistor hooked up to the positive end of the capacitor. And that goes across to the other resistor and the potentiometer there. Making sure that that is all good. Yep. And let's see, resistor to potentiometer. And then middle is fed back to our leg there. And then the other end of the potentiometer goes to positive. And that should be all duplicated on the other side. And then we have the cross-coupled bases. Oh, I think that's where I screwed up. Okay, hang on. I think I did not actually cross-couple my bases. I think it might be time for the spaghetti DuPont wires here. Let's see. Okay, I'm gonna choose green and blue. Okay, so we are cross-coupling these guys. So we go from the base of one, which is the middle, to the resistor capacitor junction of the other one. Yeah, I definitely didn't have this done right. Okay. And then again, the base of this guy, cross-coupled, that's not in yet, to the resistor capacitor junction of this one. All right. Let's see if that, hey. Oh,
did you get it?
Worked for a second. Oop.
I think you need to adjust your pots.
Yeah. Oh, it's just really slow, I think. So it is working. Yeah. It's just super slow. Whoa, yeah, I've never made one this slow before. Well, that's kind of cool.
You're only using 5 volts?
Yeah.
Yeah. Okay. So if you use 12 volts, it'll go a lot faster.
Yeah, there we go. Now we're starting
Or
to
in that
blink
case,
with gas.
yeah, you reduced your base resistance.
Yeah. Yep. So that's all the way. Yep. Hey, check that out. Woohoo!
Cool.
Awesome. Yes.
Yeah.
I love it when a circuit works.
Yeah. It's so anyway, I mean, basically my bird circuit is exploring, well, really, I mean, I'm interested in consciousness. What is consciousness? Where does it come from? And Nikola Tesla famously said that if you want to understand the secrets of the universe, think in terms of energy, frequency, and vibration.
Hmm.
And if you study the Hermetic principles, so I'm interested in spirituality and religion and philosophy, and pretty much all schools of thought come back to like everything's energy. We all know that. Like even physicists are like, people, that's the way it is, right? And everything's vibrating. So at the basis, reality is just vibrating energy. So falling on that philosophy, I wanted to see if I could manifest analog machine intelligence by just putting vibrating units into relationship with one another.
Mm-hmm.
So if you can make a circuit that sings like a bird using only a couple of oscillators, which let's say, if you think about each transistor as being a neuron, so if you have 5 oscillators, that means you have 10 neurons that are coupled together, triggering each other. Like right there, you have a pair of neurons. So that's only 5, and I can make a circuit that produces kind of convincing bird sounds. So, what happens when you have 100,000 neurons? What happens when you have 80 billion neurons, like the human mind?
Mm-hmm.
It doesn't scale linearly.
No.
So you get some pretty cool stuff.
Yeah, I mean, even these 5 oscillator circuits like coupled together, I think would be very, very difficult to model,
Yeah.
all of the interactions to them. And so it's interesting how how a relatively simple base circuit, once you start adding them up together and thinking about how they interact together, it gets very complex very quickly.
Yeah.
And that's what's so interesting about the birdsong, is that you can actually hear that complexity. You can hear that, everything isn't like lined up, perfectly in tone. And so you get all of these very interesting, audio wave interactions that produce, like a little chirp that goes up or one that goes down, and, the different times and pauses and things like that. Yeah, super interesting.
Eventually, when all of you can have one of these bird circuits to play with, which I'm working on, as you're twisting the knobs, what you'll notice is that it's not just that one knob does the same thing. It depends upon the state of the circuit for precisely what you were talking about. So, I mean, I'm not saying that, it's infinitely complex. It's not, right? I mean, there comes a point where you're like, all right, I get it. I've sort of explored birdsong. But, it's actually, there's a lot of like tweaking and messing around you can do. And the circuit will sometimes get stuck in a modality where you're like, wait a minute, like I used to be able to generate more complexity and now it's like getting less so. And then all of a sudden, like one twist of a knob and boom, it's off in a completely different state. It's just wild. I think that's really cool.
Yeah, definitely.
So, definitely. Yeah, I mean, think about it. Our brains, I mean, scientists talk about brain waves, and we know that neurons are just generating these electrical impulses that behave very much like a capacitor that charges and then discharges, right?
Yep.
And we also know that synapses in the brain are connected through, the fluid surrounding all the cells, which is another form of capacitive coupling, really. So, yeah, it's quite fascinating if you think about it, like how the charges build up and how certain thought patterns would begin to reinforce themselves by building up more charge and more structure. I'm just saying, people, you might be a circuit.
Pretty sure we are.
Great. Yes. So more analog electrical engineers need to get into this field so that we can start to understand consciousness in a much broader sense. Like I like to say, there is no digital ghost in the machine. The machine is an analog ghost maker.
Well, I mean, even digital circuits are all analog when you boil them down, right? When you get to the nitty gritty, they're all transistors and resistors and capacitors. Yeah.
Absolutely. They are, but they are also designed to minimize the analog effects by like intentionally ignoring the analog behavior in favor of only looking at, the binary code structure.
Yeah.
I mean, of course, digital is great. I'm not trying to be like digital basher or anything. I'm just trying to be analog advocate.
Yeah, I like it. Analog advocate.
Yeah.
That's a good term. There's
It's a better form of AA than the alternative.
Cheers to that.
I'm drinking my water.
Bob was saying that that kind of this whole conversation makes him think about the book, The Art of Electronics.
Oh,
and
yes.
Yeah, it's such a great book. And yeah, there's been some love for that.
Class at Harvard with Paul Horowitz.
Oh, nice.
Very cool, yeah. I hear he's at SETI now.
You hear
I know he was always at SETI. He was always doing stuff with SETI.
Interesting.
But I think, well, anyway. But talk about a good analog electrical engineer. Wow.
Right. Yeah. I love the tone that book is written into. It's a great anti-textbook kind of, I mean, it's still sort of textbooky in ways. It is definitely a tome, but I like that there are actual jokes and playful language in there. like a human wrote it, right? Like
it's one of my goals in life that before I die, I want to be able to understand everything in it.
Ooh, that is
I started out, I would say, so I took that class pass fail, and I mean, I like eked by. And this was more than 20 years ago. And I remember there were years, it's always just been one of those things where, like, as I'm learning more and more about analog electronics, I'll pick it up, I'll be like, I wonder if I can understand it now,
Yeah.
And I'm like inching my way through, like, I'm like, okay, well, I got that page and this page, but it's kind of paragraph by paragraph.
Yeah, but that's also just how you learn. You make projects and they teach you things, and then other things that seemed difficult or obscure, really, like all of a sudden you have the context to understand them and more experience to do that with. So yeah. That makes sense.
Yeah.
Oh, so question, have real birds responded to your deep fake birds at all?
So I love that question. The answer is sadly, I don't know. And the reason is that in order for me to know, I need to set my birds up outside for a longer period of time and go away, meaning like enough distance that, I'm not interfering. And what's my excuse? Basically, my excuse is, well, number one, that they, it would have to be a sunny day. That's not even an excuse because I can get that. I guess I've just been really busy.
Yeah.
Yeah.
I'm just saying, I think somebody should fund that study.
Well, I think somebody should fund anything I do. Like, I'll just start with anything, you know? Like, because yes, that would be nice. Yeah.
Yeah.
So here we are. So yes, I will do that, and I will make eventually with lots of money coming in my direction. Ha ha ha! But I'd like to make birds that talk to each other.
Yeah.
So
That'd be cool.
my birds in circuit garden all have wires that run back to the main controller panel, which is my tree of life circuit. For those of you who know what I'm talking about, it's just basically like relay switches that sequence the entire installation, so the birds aren't singing all of the time.
Cool.
But anyway, but that particular switch, like, it doesn't necessarily need to be controlled by relay. It can be controlled by, and like infrared communication. It can be controlled by radio. So I'd like to develop. I'd like to develop a whole flock of birds.
Yeah.
That have like some simple perceptual abilities, so that they can affect each other, and even better, if using the same analog principles when they communicate with each other, it actually affects the vibration, the syntax, so to speak, so it modulates their song.
Nice.
I have to say though, for any of these outdoor bird experiments, if I find that real birds are getting upset, the fake birds are coming inside. I'm a lover.
That seems reasonable. I mean, I wouldn't see why real birds, like, as long as it was like kind of relatively close. I mean, real birds respond to the fake bird call things, right?
Yeah.
So why wouldn't they respond to
they would.
making bird noises, right?
I mean, for sure, mockingbirds would definitely respond. Absolutely. I'm just saying that there is in the back of my mind this like slight concern that when my fake birds are deployed on the world, I just hope that like it benefits real birds, not hurts real birds. That's
all. You don't want them to be the evil deep fake birds.
No.
We want benevolent deep fake birds.
No, definitely. I mean, in fact, one of my career goals is to generate enough profit from my electronics practice to donate a percentage to wildlife conservation, because
nice.
The circuits that I developed are inspired by nature, because nature is so tremendously magnificent. And while a bird circuit is cool, it's nothing compared to real birds. And it's so critical that while we become increasingly engaged with technological media, we don't forget that the earth really needs our stewardship, right?
Yeah.
We need to go outside and hug trees and love real birds and all of that. Important.
Definitely.
Yeah.
Definitely. Have you done any other kind of analog sounds? Like, I'm thinking like something that would be super cool is to do something like this, but try to make sounds of like water running through pebbles on the beach, like things like that.
Yeah. I have done that.
Cool.
I used that technique in some of my soundscapes that were part of a show I did in 2012 called the Parallel Series.
Ooh.
And I did that using basically white noise generators, where I slowed down the pace enough that you got kind of like a warble effect. So I've also made the sound of crackling fire in a similar way. Again, white noise generators, very, very useful way to approach it. You can also just use a transistor for noise generation. In fact, if you look up my Pretty Bird schematic, I used a transistor for noise generation there, and you could apply a similar principle for other types of sounds. I've made frogs, crickets, bees.
Ooh, nice.
What else? Moths. They don't make sound, but I have like a big electrolier full of blinking moths.
Nice.
I'm probably forgetting something. Oh, I mean, sometimes like when I'm messing around with my bird circuits, suddenly they sound like, well, definitely like weird outer space aliens. I definitely get that, but I've also like had it suddenly sound like a cat.
I could see that. Yeah.
You know, you can kind of get that woof woof of the dog. In my quacking duck, I achieved the duck quack like tonal quality by using a modified wah-wah circuit, like you use guitar pedals.
Nice. Nice.
Yeah.
Cool.
Crickets
How did you go about like getting the funding to like work on and build the circuit garden? Was that something that was like completely funded like by a grant or something from the start, or did you just build it and have to kind of like seek out funding, or how does that work?
The circuit garden was a commission by Arts Brookfield. So they paid for the creation of the work, or I had a certain budget, a nominal budget to work within for the creation of the work. And the deal was they financed the creation. I exhibit it with them for a certain period of time, and then when the exhibition is over, I own the installation, so I reserve the right to sell it and then make a salary, basically.
Right.
Yeah.
Cool.
That remains to be seen, but I'm sure some of you on this video call would love to buy it, and I'd be so happy.
Heck yeah. I mean, come on. If people can just like buy Twitter overnight, right? They should be able to. Everybody will buy a circuit garden.
I mean, Elon Musk definitely needs a 21-foot long circuit board in his living room, right?
No, your art is too cool for him. He's not worthy of it.
I mean, if Elon Musk wanted to buy it, I'd be okay with that, because then I would be able to redistribute the wealth to
there you go.
More cool electronic art.
Heck yeah. That's awesome. So do you have any other irons in the fire right now that you can talk about, or any other projects that going on?
Always many irons in the fire with me. Well, I talked about my electronics fashion. I talked about the fact that I'm developing a commercially available version of my bird circuits.
Yes, definitely keep us posted with that.
Well, if you follow me on Twitter, or Instagram or whatever, I'll announce everything there. I'm in conversation with a colleague of mine who's a great audio engineer, and we're both really interested in spirituality. We would like to develop a large Tibetan Thanga style aesthetic printed circuit board that generates the sound of Om, so that human vocalization. So basically like a chanting Buddha circuit. Aesthetic circuit board printmaking is something that's really interesting to me as an artist, and so I want to continue making aesthetic. So the function, yes, being what it is, which we've kind of focused on tonight, but like, for example, you've seen the boards in different shapes, but like, I'm really interested in just the expressive language of the aesthetic circuit board printmaking itself. I'd like to I haven't had any time recently because I've been so busy with other things, which is always ever the problem for everyone, right? But I'm trying to carve out some time with no distractions to work on a series of paintings where I paint how I see electricity flowing through a circuit. This is
Ooh.
something I'd like to be able to share with people, and the way that I perceive electricity running through circuits is also how I perceive electricity running through all things, and hence my interest in spirituality and yoga, and like I see auras, and I'm also a perfumer.
What is that?
I make perfume.
Okay. All right. I'm like, do you smell perfume? Do you like, that's
Well,
cool.
like I literally make it from
Yeah.
scratch. I have all, I have hundreds of ingredients, and I researched old perfume formulas, and I own the Virginia Perfume Company. Anyway,
Ooh.
so I have some like synesthesia thing. Like there's something, I have a very analog electronic brain. Like it's all like weirdly fuzzy and connected up there. And so the way that I make perfume and the way that I paint and the way that I build analog electronic circuits is all very intuitive. And that's something I'd like to try to make more visual, I think, through painting. But as soon as I say I'm going to do it in one medium, then I'm like, oh no, I need to express it in this other way. So.
Oh, so we have a question of, can you pair scents with circuits? I will say the only scent I've ever paired with a circuit has been that burnt component smell,
Yeah.
which I do not recommend.
Imagine that's not what you mean. So
No.
I have designed perfumes that correspond with the chakras, and because the chakras are correlated with colors, you could certainly, and I have made kind of kundalini or chakra diagrams with vibrating color. So you could make that comparison. I made a kit for my show Pollination in 2015 called Be the Flower.
Ooh.
And that kit had a perfume for each chakra that you could paint on your body. So you could paint the scent of your chakras.
That's cool.
I don't know if that answers your question, but
well, there's some suggestions. Scratch and sniff solder mask. That would be pretty funny. Man, what happened to scratch and sniff stuff? I haven't seen anything like that in years.
I think that's probably just because you got older.
Maybe, yeah, probably. No, don't tell me that.
No, just like hang out with some kids and they're all like scratching and sniffing.
Oh, man. What is that's it's interesting, like the subject of like how do you make perfume is kind of interesting to me. I dyed yarn for a little while and I used natural dyes, and so I learned a lot about how dyes are made and what plants create different colors and how you can modify the colors and things like that. And so I'm curious about perfumes because, I mean, not knowing anything about it, I would imagine that a lot of it is probably plant-based, but maybe some of it is not. Are there other things? Are there surprising ingredients in perfumes? I mean, I'm sure that there are in like,
surprising. I mean, my
yeah.
gosh, there's all kinds of incredibly interesting ingredients in perfume. There's the naturals, some of which are animal derived, the majority of which are plant derived. But even in the plant realm, you have everything from things that are like extracted by a steam process, steam distillation. You have materials that are extracted by techniques such as enfleurage, although that's like quite time labor intensive, so it's not really done. There's solvent based extractions, all depending upon the water or solvent solubility of different aromatic compounds. There are resins. There are gosh, what am I forgetting? Well, anyway, so the natural realm, and then you have the synthetic realm, which is also absolutely incredible. Like I liken, so my perfumes emphasize natural ingredients because I just prefer them. They're richer, they're softer, and plus it's incredibly difficult to find real perfume that uses natural ingredients. It's just not common in industry anymore. But I liken the palette that a perfumer has, the natural ingredients would be analogous to like naturally available pigments for a painter.
Mm-hmm.
And if you didn't have the like bright, punchy synthetics like the neons and the whatever, it's like you're missing something. And so the artful combination of both is really what makes perfume achieve its highest level. Like an all natural perfume cannot compete with a perfume that is enhanced correctly with synthetics. And by correctly, I mean like not substituted or replaced or cheapened, but like truly enhanced. And otherwise, making perfume is a rule-based practice like analog electrical engineering, where once you understand the basic principles and once you understand your ingredients and how they interrelate, then you just get creative with it.
Yeah, I could totally see that.
The way that we experience scent is quite similar to how we hear sound. In other words, like certain scents can cancel each other so that you smell nothing. And that's a very frustrating and expensive lesson to learn as a perfumer if you don't, if you, for example, say, oh, well, this like wonderful $400 bottle of Rose Otto would smell great if I just added all of these other floral ingredients to make my like most favorite flower smell in the entire world. Well, sometimes that results in something that smells like nail polish.
Yeah, that's very interesting. Yeah, I can definitely. There are a lot of similarities with dyeing and interesting.
Just it's the same thing as saying, oh, I love all these colors. I'm going to dump everything in and be like, oh, and then I just made like a muddy brown.
Exactly. And also how like especially with yarn where you'll have different yarns that have many different colors in them, and synthetic dyeing is by far like more popular, like less time consuming, like cheaper ingredients, that kind of stuff. And the different kinds, you can just do different kinds of combinations of colors with synthetic dyes than you can with natural dyes. And you can definitely get sort of like poppier things. Definitely. Yeah, that's interesting. And I think it's also interesting like what draws us to different smells as well, like because we all might not feel the same about a particular smell, right? Some of us might love a certain smell while other people might hate it, and that's also very interesting.
Olfaction is actually quite a mysterious thing, and there's still a lot of research going into like what is it exactly that's happening when we smell something. What we do know is that when you smell something, like your body's actually directly interacting with that chemical substance, which is kind of a gross concept given some of the things that we smell and we don't want to do, but that's how it is. But yeah, olfaction, scientifically, I mean, fascinating field.
Yeah. That kind of reminds me, what was it, Brave New World that had the smellies in them? Like the movies that also had smell, like senses of smell that were foisted on you? Or was it like the feelies or something? There was definitely
that book, but
there's definitely like a dystopian novel that featured movies that had like a smelly component to them, which I always thought was like super weird. I was like, oh, I don't think I would want that.
Well, certainly in my perfume business, I focus on scents that are incredibly pleasant.
Nice.
Yeah.
Nice. That's super cool.
Yeah.
Awesome.
I know people are probably like, how did we go from talking about analog electronics to talking about perfume? But in my mind, they're very closely related.
It's it's what happens in a conversation with me, at least. So
Okay.
you know, you get to yarn, you get to electronics, you get to whatever it is that's interesting, you know.
Oh, well, I am definitely like that. I mean, I'm a tarot reader. We can talk about tarot.
That's interesting. I have shied away from things like that because I'm just like, I don't want to know. I don't want to know. I don't want to like pregame my psyche to think that like something is going to happen because.
So tarot is an instrument to look deeply into the present.
Oh, interesting.
And so to say that you don't want to read tarot is kind of like saying that you don't want to go through psychoanalysis. It's like, well,
yeah.
It's there and it's acting on your subconscious mind. So why not bring it to the surface and just deal with it?
There is that. Not being avoidant. Oh, come on.
Yes. Well,
there's the suggestion of like you could put a thermal heater under scented fabric to release certain scents back to like the circuit. Can you pair circuits with scents kind of a thing?
Well, and those already exist, right? Diffusers.
Yeah, pretty much. Yeah. There you go.
Yeah. Now
that's interesting. I haven't seen. I mean, I've seen, you know, a lot of visual circuit art, things that move. I don't think I've seen anything that incorporates like scent and circuits or like scent and in a like kind of electronics techie kind of a way, right?
Well,
interesting. Like people tend to make things with LEDs. Like
there's an installation at Tate Gallery last year where there were these suspended flying like robotic creatures that were releasing scent into the room. I didn't see it in person. I just read about it. But
interesting.
Yeah. I mean,
yeah, that's interesting.
You know, the wonderful thing about all of our different senses is that they are incredibly different. And so, what's possible in one realm of experience may not necessarily relate back to another. You know, the action of electricity flowing through a circuit relates well to sound and light. Sound really, I think, best of all. I mean, or movement, kinetic sculpture, but I think sound is, in my experience anyway, the best way to experience what's happening in a circuit.
Yeah.
And scent, you know, interestingly, perfume is very electricity-like in the sense that it's immaterial and evolves over time, and it has this very kind of, mysterious, intangible quality to it that we can sense, but we can't really understand. Electricity is like that, right?
Yeah.
So I think that's why, in my mind, they are so similar. But it's almost like perfume needs to be converted to sound. It's like perfume. Yeah. I mean, that's why in the New Age movement they correlate experiences of energy with color. And I have to say, in my own like synesthetic sensory experience, I do find that the color assignments are generally accurate. And you also see that reflected in tarot as well. Tarot is very interesting because the cards have a certain energetic resonance, and so they talk to you. It's wild. You shouldn't be scared of it.
I don't know. It's always, I have not done any kind of like serious reading about it at all. I'm just like going off of how it's basically portrayed in the media, right? Which is always this very mysterious and scary thing after which bad things happen. So
you mean like electrical engineering?
that too, yeah.
Robots like Frankenstein, I mean, whatever. Like, try to scare you away from all the good stuff. This is modern magic. I mean, electrical engineering is magic.
It is pretty magical.
Yeah.
And there's definitely an element of delight with still remaining just like a tiny bit of surprise when something actually like works.
Yeah.
And starts working, right? It's like, oh my gosh, it really does work.
Exactly, because I think any engineer, if they're being honest with themselves, would say like they don't 100% understand what's happening in a circuit when it works.
Yeah, we had this conversation. We had a really cool person come into a class that I'm taking, an embedded programming class. Which, by the way, if anybody listening is thinking about taking Alicia White's embedded programming class, you totally should. It is amazing. But yeah, so we had a speaker come in and talk to us about designing computer chips, right? And it's so interesting because, like, right, this is the thing that we're interacting with. We're going to a class to learn how to use them and things like that, and yet there are so many layers of how those are made, and so much like lifetimes of specialized expertise that goes into making and creating and producing and manufacturing a computer chip before you even get to use it or program it, right? Like just a blank chip, that it's kind of mind-boggling. And we like, there were a few of us who said during this during this chat, like, man, I wish I had, a dozen lifetimes to live, because each facet of this sounds so interesting, and no one person can actually know all of it. It's kind of amazing and surprising that that chips actually get made, and that we can actually use them, and that they actually work. Because it's such a group effort.
I mean, it really is the development of a new intelligence. Machine intelligence is no joke. Like, human beings are facilitating a new form of life. At least if you don't want to go with life, we're facilitating a new intelligence, full stop. Yeah. And if you look at our own bodies and you think about the eons of architectural layers that went into creating cellular metabolism and organs and the whole thing. Oh my gosh, right? In many ways, like when I look at microprocessor development, I'm seeing that same kind of genesis. I mean, it's a different thing. It's happening on different time scales, but just because humans are involved in the creation of it doesn't make it any less real.
Yeah.
There's a really interesting book by Karen Smith on 7 Clues to the Origins of Life, in which he talks about the affinity between organic molecules like oils and silicon. And he talks about, back in the day, a long time ago, when there's no life on Earth, that the sand, the silicon along the edges of riverbanks would, in areas where the water flow wasn't so extreme, build up, and any organic molecules that were flowing downstream and would come into proximity with them would develop an affinity, right?
No.
So we know about silicon being a crystalline structure that in a saturated solution, it begins to self-replicate and form, more complex crystalline structures, right? Like sugar bars or whatever.
Mhm.
So what if these silicon structures in their affinity with organic molecules began to build up like the original RNA structure? Anyway, not my idea, but I just love that. So he's like, what if this happened, right? That basically silicon encoded the origins of RNA and DNA based life forms, and now like we're just giving it back.
I like it. I like it.
Yeah, I love that theory. I think it's fantastic. People give him a hard time because he like makes these, you know, pretty radical claims or stretches, but you know, why don't we have more space for that in the world? Like, I don't know. Sometimes I feel like we're too hard on ourselves. I guess if you're trying to say like, oh no, this is fact, and you present it as like science, like this is real, this happened. Okay, I can see where that's problematic. I mean, I know that we can't do that as a culture. We definitely need more space for, you know, people to be like really radical creative thinkers and not be shot down. We should just all call ourselves artists.
There you go. Oh.
I mean, it is a funny thing, right? That people get older and they get so serious and they squelch that childlike curiosity that's native to every human being. Why do we do that?
I don't know. I am making a point to not do that and to surround myself with as many stupid toys as I can. You know, I mean, we definitely have a love of just blinking LEDs here and and delightful silly things, and I think that that's good. It's good to have like things that bring you joy in your life and that make you happy.
Absolutely, because things that make you really happy put you in that state of openness and receptivity, and that's the mind frame you need for radical innovation.
Yeah,
that's when discovery really happens. When you really like open your mind and be like, okay, I'm not going to judge. I'm just going to try this, you know. And I'm not saying within that scope you don't still have to, you know, furrow your brow and work really hard and push through problems of being like, oh wow, maybe I really did try to build a flying carpet and it's not working. You know, but still, if the idea of building a flying carpet or a magic carpet makes you super happy, like you stick with it. My guess is that eventually you're going to build something really amazing that will delight and inspire other people and possibly invent some new technologies in the process, right?
There you go.
Yeah.
There you go. Yeah.
Anyway, I just don't know.
You'll never know until you try.
No, you won't. But I just don't understand why adults like go out of their way to shed their childlike curiosity, you know?
Yeah, and I feel like there are, I don't know, there are socially acceptable ways to be childlike and like not socially acceptable ways to be childlike. Like there's some weird social structures and code around that, right?
Yeah.
And like I think that video games are being more accepted as like a legitimate adult pursuit, right? Where they didn't used to be. Yeah. And so like now that's okay to be childlike in that way. But
well, like why couldn't adults just go to the park and like play Twister? Like, I mean, so what? Like nobody's getting hurt, you know? Like what if they're just having a really good time? And I mean, there's so many adults that would be like, that's too playful.
I mean, I climb colorful plastic holds on like fake rock walls every week because it's fun. Right? Like that is a silly pursuit. It is ridiculous. Let me you know, there's no reason.
Or why? No, but why are we only allowed to dress up on Halloween?
Yeah.
I mean, just wondering. I mean, now like it's approaching 10 o'clock, so I'm like getting like wackadoodle on.
That's fine. So we have some good comments that adults are just broken children, in my opinion. And we have some Lego love. Yeah, there's a lot of people are really into Lego. That's true. Yeah. Oh, funny.
Yeah.
Cool.
Well,
Here for the wackadoodle. Yes. Yes.
well, it's definitely been fun to hang out.
Definitely. Yeah, I suppose that we should probably like wrap it up. It's getting close to our 7 o'clock time, but yeah, thank you everybody for joining and for all of the excellent questions and engagement. It was super fun to see what you all are chatting about and to answer questions and stuff like that. And yes, we will have a plethora of links in the description afterwards, and like in a day or two. And yeah, definitely want to keep up with you, Kelly, in terms of like what you're doing and the fashion, and definitely like the bird kits. Yeah, it'll be good.
Oh, sure. I mean,
Whatever.
we all follow each other on Twitter.
On Twitter? Is that, yep. Yeah, Twitter, Instagram, any other platforms that you're on that are good to get a hold of you? You have a website, newsletter? Do you have a newsletter?
Yeah, I don't mess around with that anymore. I just push stuff out on social media. I mean, you can follow me, yes, Twitter, Instagram. I occasionally put videos on TikTok, but that's more just like something I mess around with. For news, I would say Twitter and Instagram.
Cool.
Yeah, everybody gets too much email. Right? I mean, by all means, please email me if you want to talk to me about something, but I'm not going to send you a newsletter. Sorry.
Well, we'll mention you in ours.
Thank you. Well, yeah, but good for you for having the time and energy to do it and not have it go to people's junk mail.
I have help. I have excellent newsletter writing help, who's actually one of the people in the comments here who's been asking some questions and stuff. Thank you, David, for your excellent newsletters. Yeah, I can't do it all myself. No way.
Right now, I'm doing everything by myself, and that is definitely a big driver of the wackadoodle. Yeah.
Oh, cool.
But that's about to change.
Ooh,
yeah.
Nice.
So that'll be good.
Yeah, definitely.
Yeah.
Cool.
Yeah,
all right.
Hopefully we can hang out when I come out west. You're in San Francisco?
I'm in San Luis Obispo, so it's a little bit south. Yeah, basically kind of halfway between San Francisco and LA on the coast.
You are like in heavenly beautiful territory.
I enjoy the nature that surrounds me for sure. Yeah. It's really nice.
Oh my gosh, it's so gorgeous. Well, yeah, I haven't been out to the West Coast in a long time, since pre-COVID, so it's time for a return trip.
Yeah, definitely let us know when you're stopping by.
I will.
It'll be fun. Cool.
Well, thanks for having me.
All right, no problem, and we will see everybody next week. Woohoo!
Bye.
Bye.